Hi everyone, welcome back to CHM421 Analytical Chemistry. In this video, we still in the topic of trimetric analysis, focusing on complexometric titration. So this video will discuss about calculation related to complexometric titration. So we will do one by one all the example together. As usual, we have to read all the information given in the questions carefully. For example, in this question, 50 ml of sample 50 ml of sample underground water is acidified with hydrochloric acid. Boil to remove and neutralize with sodium hydroxide. The solution is buffered to pH 10 and titrated with 0.014 molar EDTA using EBT is indicator. The titration required 31.63 ml to reach the endpoint. Calculate the water hardness is ppm of calcium carbonate. Okay, so see what kind of information we have here. A 50 ml of sample is acidified to remove, neutralize, and so on and so forth. The buffered in the titrate with EDTA. So we have titrant in the burette. So the titrant titrated with EDTA using EBT is the indicator. The titration require 31.3 ml reach point. So meaning that the titrant in the burette is the EDTA with concentration of 0.0124 molarity and require 31.63 ml to reach the endpoint. So what is the analyte in the Elimia flask? The analyte is a 50 ml of sample. So it's a sample of 50 ml. Acidified with chloric acid and then neutralized with sodium hydroxide. That's the process. So the question is calculate the water hardness. The water hardness is ppm of calcium carbonate, meaning that in this sample, we want to know what is the concentration of calcium. Okay. Of course, the analyte will add indicator, which is ABT, but this one is just additional information. So now we have to calculate the water hardness using the water hardness is the ppm of calcium carbonate. Okay, how do we do it? So we know the reaction will be calcium reacted with EDTA to produce calcium EDTA complex. Okay, so we know from the equation 1 mole of calcium will be reacted with 1 mole of EDTA. So yeah, this is the equation. So as I said just now, 1 mole of calcium reacted with 1 mole of EDTA. So 1 mole of Ca reacted with mole of EDTA. And then we can calculate what is the 1 mole of Ca, because we know EDTA, the information is already given here, molarity and volume. So from the formula of molarity, we can know what is the mole by using formula of mole per liter. So why it's mole calcium carbonate here? Because we know it's asking about the hardness of calcium carbonate. So calcium carbonate. So meaning that calcium carbonate is containing of calcium 2 plus and carbonate ion. So in this case, 1 mole calcium carbonate is related to 1 mole Ca plus. So we can straight away to calculate, because we want to calculate the ppm of calcium carbonate later on. So we can calculate the mole of calcium carbonate, because we know the relationship is 1 mole relationship to 1 mole. So 1 mole of calcium carbonate can be calculated from the mole of EDTA. So the information given from the EDTA is the 0.124 molarity, 31.6 ml. So the mole per liter, this is the molarity just now, 0.0124 molarity times by volume in liter. So 31.63 ml have to be converted into liter. So when you want to convert it divided by 1000, you get 0.03163, and then uh, hold on, what's wrong with my, okay, and then you have to multiply it by you have to multiply it by the molarity 0.014, and then you can get 0. So it's 0.3922 minus 3 mole calcium carbonate. Okay, so you already get the mass of calcium carbonate and the mole of calcium carbonate, and then you can calculate the mass of calcium carbonate. So since you already know the mole, so the calcium carbonate, the molecular mass using from the formula of mole mass over molar mass. So you can know what is the mass of calcium carbonate by calculate the molar mass of the calcium carbonate. So you can calculate by using the periodic table. You can know what is the molar mass of calcium carbonate. Okay, so so hold on. So here 0.933922 times the power minus 3 mole times with molecular mass is 100 gram per mole. And it's gram per mole. So you cancel off the you can cancel off the uh, you can cancel off the unit, so you can get the 0.3922 times the power minus 3 times 100. You can get 0.03922 gram. So remember, ppm is milligram per liter for liquid or milligram per kilogram for solid. So we have to convert the uh, so we have to convert the gram to milligram. This why we have to times it by milli 1 times 2 minus 3. So the number you get just now divided by 1 times 2 minus 3. So you can obtain 39 point. You can obtain the 39 0.22 milligram. So this milligram have to this milligram have to divided by the volume of the sample. The volume of sample is a 50 ml just now. So you have to 50 ml converted into liter. Okay. So it should be converted to liters. So 50 ml divided by 1000 is at 0.05. So this 39.2 milligram divided 0.05. So you can obtain in a ppm 7. This is in ppm. Okay, the next question. Hold on. You can read the question first. Okay. The next question is the next question is 150 ml of fresh water sample 150 ml of freshwater sample was treated with ammonium chloride buffer. It adjusted to pH 10 to determine the amount of calcium carbonate. 30 ml of 0.005 molar EDTA was used in the titration. Determine the hardness in terms of part per million of calcium carbonate. It's quite similar with the previous question. It's a very straightforward. So we know the what? We know the titrant is EDTA. It requires about 30 uh, ml of 0.005 molar used during the titration. So we have a fresh water here. It's about 150 ml H2O. So now we have to determine the amount of calcium carbonate. So the water hardness is calcium carbonate in ppm. All right. So meaning that this water sample contain of calcium 2 plus. So the equation calcium 2 plus reacted with EDTA will produce uh, calcium EDTA. Okay, so we know from the equation similar that we write just now. 1 mole of calcium reacted with 1 mole of EDTA, and we know calcium carbonate is containing of calcium and also carbonate ion. So 1 mole calcium carbonate same goes to uh, same goes to 1 mole Ca2 plus. All right. So as I mentioned just now, 1 mole of Ca reacted with 1 mole of EDTA, and we know 1 mole of calcium carbonate also reacted with 1 mole of Ca. So we can calculate directly a mole of calcium carbonate from the mole of EDTA. So the information of EDTA is EDTA is containing of 30 ml with 0.05 molar. So 0.05 molar mole per liter, and then times with 30 ml, ml is converted into liter. So you can obtain the 30 ml over 1000 and then multiplied by 0.5. So you can get 1.123, 0.4, or you can write 0.15 times the power minus 3 mole. Okay. All right. So from the mole of calcium carbonate, definitely you can calculate the mass of calcium carbonate because the molar mass of calcium carbonate is 100 kilogram per mole. You can calculate from the periodic table. And then from the answer that you obtained just now, you can multiply it by 100. So you can obtain 0.015 gram. Okay. So this gram can convert it into milligram. Why you have to convert it into milligram? As I mentioned just now, ppm is milligram per liter or milligram per kilogram. So we already obtained the milligram. So liter, how many? 150 milliliter, and then converted into liter, 0.15. So you can get it in 100 ppm. Okay. All right. So this is another question. Please read. Um, okay, in this question, the FE in this question, the FE in 6.875 gram milligram of Indo plant 6.7. Okay. Uh, Fe in 6.875 milligram of Indo-plant food was oxidized into 3 plus. Following which the sample was diluted exactly 100 ml. And then calculate the percentage of Fe in the sample. So meaning that you want to know the gram Fe divided by the gram of sample, milligram, times 100. So you want to know this one. Okay. Diluted, calculate the percentage of Fe in the sample. If 44 80 ml of the diluted solution was needed to titrate the 15 ml of 0.0036 molar of EDTA solution. Okay, what is the information that we have in here? So calculate the percentage diluted needed to titrate. Okay, so meaning that we have a titrant, which is EDTA. So this EDTA will need 15 ml with 0.0036 molar. So the analyte in the sample, what is the analyte in the sample? Calculate the percentage of Fe in the sample if 44 diluted sample, sample in 44.87 ml. This diluted sample, 4487 ml sample obtained from 100 ml. Okay, so in this 100 ml of solution, we add on 6.875 milligram of sample. Okay, as I mentioned here, and then diluted into 100 ml. So from the diluted, and then we take it out, we get the 44.87 milliliter titrated with the EDTA. Okay. So Fe3 plus reacted with EDTA to form Fe-EDTA complex, meaning that 1 mole of Fe reacted with 1 mole of EDTA. So now we can calculate the mole of Fe3 plus. So from the information of EDTA. So EDTA just now is 15 ml, 0.06 mole per liter. The 15 ml converted into milliliter. So by using your calculator, you can obtain this number, 15 divided by 1000 times 0.0036. So you can obtain 0.0084 milliliter of iron. Okay, so the molarity of Fe, after you get the mole number, you can calculate the molarity of the Fe in this diluted sample. Okay, so molarity we know, uh, molarity is mole per liter. We know the mole number of Fe already, and then we know what is the volume of sample in the aluminum flask, 44.87. So the 44.87 should be divided by divided by 1000. So you can obtain 0.0 uh, 0.004487 liter. So 0.084 milli divided 0.004487. So you can get 0.0012 m. Okay, molarity. So now this is molarity and 44.87 ml. So now, since the 44.87 ml is obtained from 100 ml, so you have to calculate what is the molarity in 100, the mole in 100. Of course, the molarity of here is similar to molarity of here because this is no further dilution. Let's say the molarity is 0. What just now? 0.0012 molar. So in here also 0.0012 molar because this 44.87 ml is taken out from 100 ml. So whatever molarity seems with this molarity because in here is no dilution. So now we have to calculate what is the mole of Fe in this diluted solution. So mole in 100 ml, of course, same formula, but we know the molarity already. So molarity is a mole per liter. So we can calculate the mole. So the mole in 100 ml, we know the molarity, and then the volume is 100 ml equivalent to 0.1 liter. Okay, so 0.0012 times 0.1, 0.00 or 0.12 times the power minus 3. So this is also correct. So when you know the mole, you can calculate the mass because you know mole is mass over molar mass. So the molar mass of Fe from the periodic table is a 56 gram per mole. So you can calculate the mass. So 0. Times 56. So you obtain the 126.72 gram. All right. So the percentage is mass of Fe divided by mass of sample. So mass of Fe, this one divided by mass of sample 6.875 times power minus 3. So you can get times 100 because it's asking in terms of percentage. So 97.75 percent. Okay, what else? Uh, I think this is the last question. Uh, this is the last question. Also, is using the same concept. But before you apply the same concept, you have to understand what is the information given. Uh, the TL tantalum in 11.76 gram of sample was oxidized to trivalent state and treated with excess of Mg ADTA solution. So meaning that the titrant is Mg ADTA. So this is the chemical equation of the reaction. The free Mg2 plus required 13.34 milliliter of 13.34 milliliter of 0.0256 molar. All right. So now you have to calculate the ppm part per million of this Ti SO4. So the analyte in the sample in the eliminated flask is a sample about 11.64 gram. So it containing tantalum. So we know from the chemical equation, 1 mole of tantalum reacted with 1 mole of Mg-ADTA. So we already know this Mg-ADTA molarity in milliliter. So we can calculate the number of mole by using molarity is mole per liter. So we can obtain the mole of ADTA. So the 13.34 ml have to divide it by 1000 to get in liter times with 0.0256 mole per liter. Okay, so this one. And then 13.34 divided by 1000 times 0.026, you can obtain the mole of ADTA same to the mole of TL, 3.4. Okay, right. So in TL2SO4, you know this is TL ion plus this O4. It's not enough space. So TL 2 is O4, TL is O4 2 minus, so this one is 2. So we know 2 mole of TL will reacted with 1 mole of uh, 1 mole TL2SO4 related to 2 mole TL. So in order to know 1 mole of, so you know already the mole number of TL, T.15 times the power negative 4 mole. So you can calculate the mole of TL2 SO4. All right. So 3.41415 the power of minus 4 times times what? Times 1 divided by 2. So the answer is 1.7 075 and the power of minus 4. Okay. So mass of TiSO4, you have to calculate the molecular mass of TL2SO4, and then you calculate with multiplied with the mole number, you can obtain the mass. So this mass have to be converted into milligram because ppm is a milligram per liter or milligram per kilogram. Okay, so you have to convert it into what's going on. So I do it here 0.086 20 gram divided by mass of sample just now. The mass of sample is 1176 divided by 1000 because in kilo. So you can obtain 1.6 kilogram times milligram 1 minus 3. Okay. So 0.01156 times 1 to the power minus 3. You can obtain the answers. And then 0.0620 divided the answers 73 to 9. Okay, so you can obtain 7 3 uh, to 9.9 milligram per kilogram, or 7329.9 ppm. Okay. So this one seems goes to this answers. All right. So I think that's all for this video. We will continue the topic 4 in the another video on the redox titration. So far we done with acid base titration and complex symmetric titration. So we will continue on the next video on the redox and also on the precipitation titration. Okay, thank you. See you again on the next video.